Hey guys, this video contains the first hour of my new course, Frankie Trigger. If you are interested in the whole version, you'll find the link in the description. Have a nice learning! Hey guys, and welcome to this brand new course on making a hyper-casual shooting game, kind of like Johnny Trigger. Okay, so the first thing we are going to do here is create the project. So let's create a new project in Unity Hub. I'm going to select Unity's 2022.2.1f version. Let's select 3D URP to have better graphics. Okay, so this is the universal render pipeline. Let's create the project. I'm going to name it Frankie Trigger, just to avoid some copyright issues. So Frankie Trigger course, and I can create the project. Okay, perfect. So Unity has created the project for us. Cool. The first thing I want to do is some basic scene setup, okay? So I'm going to grab the global volume and disable it just to have some basic graphics right here, because I like to have some basic colors to deal with at first, you know, like just to set up the basic elements, and then we can play with the global volume and so on. Okay. Next, I'm going to remove the README and tutorial info from here. So let's remove them. And by the way, if you don't have the same window layout as I have, you can change that from here. So from the top right. So you can select the default one. I think you should have this one at first, but you can lay out your windows as you wish. So I like to have the inspector to the left, somewhere around here. The console maybe somewhere around here on the right. Perfect. I like to have my folders set up in that way with two separate windows. Cool. So let's bring this here. Okay. I don't remember how it was, so I'm just going to set the portrait layout right here. But keep in mind that you can save your layout by selecting Save Layout. And yeah, you can rename it blah, 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 as you wish. And yeah, it's going to be really useful. So let's go back to our portrait view. Perfect. So I have the project here. I can remove this one, by the way. Cool. And let's go on with our setup. Okay, so after removing the tutorial and README, what I'm going to do is select File, Build Settings, and switch my platform to Android, like so. Okay, cool. Once that's done, we are done with the basic setup. So what I'm going to do now is grab a character from Sketchfab. So open your web browser and go to sketchfab.com. Then search for hyper casual. Okay, so you can then tick downloadable to filter all of the elements to have the downloadable characters. So right here we've got some nice hyper casual characters. Perfect. This one is also pretty good. I've used this one in a previous course. If you've taken it, okay, you should remember it if you've taken the course. So now let's change a bit and select, let's say, this one. Maybe? Yep. 6,000 triangles. That's a bit too much. No. We are not going to select this one. So when making a mobile game, you need to make sure that the elements or models you use have a low amount of vertices and triangles. This will allow you to have better performance. Okay? So let's go down a bit more. Maybe this one. Yeah, no. What about this one? How many vertices does it have? 3,200. Okay, same thing. Okay, anyway, I guess we'll use... What about this one, by the way? Oh, this one seems nice. 900 vertices, 1,500 triangles. Seems cool. And I like his style. Okay, awesome. Let's use this one. Cool. So let's download the 3D model, and thanks to Daniel Jean for uploading this character. So the original format is GLB, so I'm going to download it. Select your projects folder, assets. I'm going to create a new folder for the models. Okay, and yep, let's save it right there. Okay, awesome. So now let's open the folder. Cool. I'm going to unzip it. So extract it here. Okay, so source, here we go. Nice. I can remove the zip file. Go back to Unity. And now I have it right here. Awesome. So by default, Unity can't read GLB files. So what you will need to do is either download an FBX character, okay, from the asset store or from Sketchfab or anywhere else. Or you can open Blender and convert the GLB file to an FBX file, okay? So that's what I'm gonna do. So I'm gonna upload it, I'm gonna import it. So file, import, GLB should be somewhere around here. Okay, so I'm gonna select my models folder, source, and select the character. Here we go, perfect. And I'm also going to remove the skeleton because I want to use a custom skeleton from Mixamo, okay? That's where we're going to grab our animations from. So select the head pan if you've used the same characters as I did, and hit Alt-P and clear and keep transformation. Perfect. So now we can remove the skeleton. So let's delete the hierarchy. And we are left. All right, welcome back, guys. In the previous lesson, we've grabbed a cool hyper-casual character, and now we are going to give these guys some nice animations. So let's jump right into it. Open your web browser and jump to mixamo.com. Okay, so now you will have to log in or sign up for free if you don't have an account. So I'm just gonna log in. Okay, perfect. After you're logged in, by the way, you can see the previous character I've used. You will need to upload a character. So I'm going to grab it from the folder we've used. So let's just right-click, show in Explorer. Perfect. Now I can grab it and drop it here. And Mixamo will automatically rig the character. So rigging means adding bones. Okay, so this is the auto rigger, and this should be oriented correctly. Perfect. So now I need to specify where is the chin. So it's right here. The wrists, somewhere around here. The elbows, the knees, and finally the groin. Okay, here we go. Make sure to use the symmetry and set the skeleton to standard skeleton. Then hit next. So now Mixamo will auto-rig your character, and we'll be able to add some cool animations to it. Okay, here we go. So now if we move around a bit, we can notice that our guy has some cool animations. So this is an idle one. We might use this one or another one, but yeah, let's hit next. Okay, here we go. So the first animation we'll need is an idle animation. So let's search for a cool one. Okay, maybe this one, I don't know. Anyway, you can select any idle animation you like. So in my case, I think that I will use, yeah, let's go up and maybe select this one. Okay, seems like he's ready for shooting. Awesome. So let's now download the animation. And when you download it, make sure to select FBX for Unity because there are multiple FBX formats, okay? And with skin. Let's download it. We are going to create a new folder for our animations. So animations, okay, perfect. Let's keep this one character idle. Okay, perfect. Cool. Let's now search for a run animation because our character will be running. Okay. Then we'll need a, let's say, flip animation or backflip. So for the run animation, I'm going to select this one. Seems really weird. Make sure to tick in place because we are going to move the character programmatically, okay? Yeah, this one is weird, but it's funny actually. So yeah, I think I'm going to use this one. Yeah, this one is decent. Okay, cool. So let's download this one. Okay, so FBX for Unity with skin, download it. Perfect, I'm going to save it. And now I'm going to download a flip animation. It should be a front flip, but you can use a back flip too, as you wish. So front flip, maybe this one. No, he's not in place. So the animation should be in place, running forward flip. Okay, in place. Here we go. Yeah, that's better. This one's cool. Yep, I like it. So let's download it. FBX for Unity with skin. Okay. And now we should be done for our animations. So that's great. And open back Unity. Awesome. So now all of my folders are all over the place. So what I'm going to do is create a new folder with the name of the project because we might add more assets or packages along the way. So let's call it Frankie Trigger. Okay, I'm going to select everything and drop it right here. Drop the folders right here. Awesome. Now let's open the animations folder. We can grab the idle character, for instance, and drop it into the scene. We can remove the previous character we had and hit play, just to give it a shot. Okay, so nothing happens right here. Why? This is because we don't have any animator attached to our character. So in the next lesson, we are going to set up our character, give it a proper animator, and play the animations. See you in the next one. Alright guys, welcome back. In this lesson, we are going to add some cool animations to our character. So let's jump right into it. Okay, so right now we have the character idle. What I'm going to do is right click, select prefab and unpack it. And I don't want this one to be a prefab. A prefab is an object, let's say, that you can use multiple times in your game. And if you apply a change to one prefab, it will apply to all of the other elements in your scene. So that's pretty convenient. And we are going to learn about them later on in the course. All right, so let's first rename this one character animator. Like so, perfect. Now I'm going to add a new component to my character. So this is going to be the animator component, and it will help us animate this guy. So we now need to provide a controller. So what I'm going to do is right click inside of the animations folder, create a new animator right here. Let's call it character or player animator. And by the way, this should be player animator, not character animator. Sorry. Let's grab this player animator and attach it to the controller. Cool. So we now have a player animator for our character. I'm just going to double click this animator and this should open the animator window. In Unity, this is where you drop your animations. So right now you have an entry state and any state. So let's drop the any states away for the moment because we are not going to use it. All right, so right at the entry, whenever we start the game, we are going to play the idle animation. So let's expand our character idle right here. Duplicate the idle animation, so Control D, just to be able to change anything if we want to, and drop it inside of the animator. So right now, you should notice that the entry has been linked to the idle animation. So it means that the first animation to play is going to be the idle one. And we can check that by hitting play. Awesome! The idle animation did play. Did you notice it? But it seems like it has stopped. So let me try again. Hitting play. Okay, so he's moving and not moving anymore. Why? Because at the moment, the animation is not looping. So what you want to do is double click the idle animation right here. So this should select the clip. And you need to check the loop time checkbox. So now if I hit play, it should loop properly. So let's go back to the scene view, zoom a bit more. And we can notice that the character is indeed moving. Awesome. All right, perfect. Now that the idle animation is working properly, we can add the two other animations. So let's say the running one. So again, I'm going to duplicate it, grab it and drop it here. And now you can notice that it's not orange. Why? Because it's not the default animation. But if you wanted this one to be the default one that plays whenever you enter the game, you could right click it and select set as layer default state. Now, whenever I hit play, the player will play the run animation. And it does. But again, it's not looping. So let's make sure that the loop time checkbox is enabled. Okay, perfect. Now we are going to set the idle animation back as the default layer state, or the layer default state, I guess. Yeah, layer default state. Okay, cool. And we can also add the forward flip animation. So let's call it flip. Grab it, drop it here, and this one should not loop, okay? We don't want the flip animation to loop. Perfect. So now we have our 3 animations. Awesome. Now that you know how to animate a character in Unity, In the next lesson, we are going to try and move this guy to the right because remember the game? Johnny Trigger, the character is always moving to the right. So yeah, let's see how we can do that. All right, welcome back, guys. In this lesson, we are going to move our character because he now has some animations. He should be moving. Okay, so one quick thing to note is that it's a good practice to separate your animators from your actual movement, okay? And to do so, we are going to right-click on the player animator and create an empty parent that we are going to call player, okay? So the player will be responsible for moving, and the player animator will animate the humanoid, okay? So now that we have the player, we can rotate it to the right. So we can rotate it around the y-axis by 90 degrees. You can do that for the player, or you can do that for the animator. And I would rather do that for the animator so that I don't have any rotation on my player. Okay, perfect. So I'm going to select an orthographic view by hitting the little cube in the scene. Okay, I'm going to hit this arrow to be able to center the view along the z-axis. Nice, here we go. And we can start implementing our movement now. So let's go back to our Frankie Trigger folder, right-click, create a new folder for our scripts. Awesome. This is going to be our first script here. So let's right-click, create a new C# script, and let's call it player movement. Okay, let's now select our player and attach the player movement script to it. Let's now open it, and this should open Visual Studio or the IDE you use. Awesome, here is our first script. Cool. So, for those of you who have never used or never scripted in C#, this is a class. Okay, so it's gonna be some basic knowledge here. A class holds different methods and variables, okay? So the variables are simply some data that you are going to use in your methods, basically. Let's set up our first variable. This is gonna be a move speed, okay? But this is not enough. First, we need to specify which variable type it is. So it's gonna be a float type, okay? So you could write float move speed. I'm going to go one step further and set it private so that all of the other scripts cannot use it. By default, if you don't write private, it is private, but I like to add it, okay? Just to be sure that it is private. But now that this is private, I can't spot it in the inspector. You see, when I select the player, I can spot the player movement script, but I can't spot the move speed. So to be able to see it in the inspector, I'm going to add the serialize field attribute. Now, when I go back to Unity, I'm able to edit the move speed, which is really good. No need to go back and forth to the script again to change the move speed. Okay, so now the next step that I like to do is organize my variables a bit more. So I'm going to add a label to that move speed, okay? So I'm just going to add another attribute, which is the header attribute. And the name of this category will be settings, let's say. Like so. So now let's go back to Unity. And now we can notice that it has added the settings label. Perfect. So now I can organize my variables as I go. Awesome. So now let's use this move speed. If I hit play, the player will not move because we don't tell it to move, which is normal. Okay, so now let's change that. The start method is called only once before the first frame update. But the update method is called once per frame. So where do you think we will need to add our move logic? In the start method or right here? Well, if you drop it inside of the start method, it's going to be called only once. But we want to move the character on every frame. So we need to write our logic inside of the update method. So let's go step by step. To move the character, we will need to access the position of the transform component. So we will need to move it to the right. So increase the x variable, x value of our position right here. Okay? So let's set it back to 0. Go back to our script and write transform to access the transform component dot position. But unfortunately, we can't write .x, so transform.position.x to access the x position, the x value equals blah, blah, blah. Okay, this is not right. And what's the error here? You can't modify it because it's not a variable. This is a structure, okay? The position data is a structure. To change that, you need to access the position directly. So we are going to grab the position and increment it on each frame by, let's say, vector3.right. So this is the right vector times our move speed. Now let's go back to Unity, hit play, and our player has disappeared. Why? Because it's moving too fast. Let's look at the grid. Look at the grid movement. Okay, that's too fast. So I'm going to diminish the move speed. Let's say .1. Hit play. Now it's better. Okay, he's moving at a decent speed. A bit too fast in my opinion, but yeah. So let's reduce it a bit more. Here we go. But that's not enough. Now it's moving to the right. Okay, that's cool. It's pretty nice. But different devices have different clock speeds. Okay, so the update will be called at different speed intervals on different devices. You're not going to have the same speed on low-end devices or high-end devices. So to test the frame rate, you can actually call the application.targetFramerate variable and change it. So let's say we run at 10 frames per second. And by the way, just to avoid going back and forth to our script, we can set it as a variable. So let's create a new header for the testing. Okay. Let's say serialized field, private, float. Well, let's set it as an integer, frame rate. Okay. So now we can configure our frame rate like so. Perfect. I'm just going to set this in the same line. I like to do so. And let's actually hit play. Let's actually set our frame rate to 10 frames per second. Like low-end devices might have 10 frames per second. And you now notice that the player is moving slowly, which is bad. And if we had 60 frames per second, the character is now moving much faster. So how can we deal with this frame rate difference? Well, there is a quick solution. It is to multiply your speed by the time.delta time. So time.delta time is basically the interval in seconds from the last frame to the current one. So the difference in time between two frames. So let's now go back to Unity. Let's hit play. All right, so the character is moving slowly. So I should increase this to 1. That's better. So remember that speed. Okay, I'm going to set it back to 1 and change the frame rate to 10. So even though we don't have the same frame rate, now the character is moving at the same speed independently of the device clock speed. So that's cool. We've dealt with that issue. I hope you've learned something right here. So yeah, that's cool. So now I can remove the testing, and I like to have my target frame rate set to 60, just to have a smooth gameplay. Awesome. Now that we know how to move our character, I like to declutter my update method. So I'm going to set this logic inside of its own method. So let's call it private void move player, or just move. Yeah, move seems okay. So I'm going to remove this, drop it here, and call the move method from the update method. Now if I go back to Unity, I should have the same behavior. And that's the case. Awesome. So now we know how to move our character to the right. But he should be playing the run animation, right? Because he's now still playing the idle animation. So in the next one, we are going to learn how to do that. Stay tuned. All right, welcome back, guys. In this lesson, we are going to learn how we can play the run animation whenever we start moving to the right. So for that, you can add the logic to the player movement, or do like me and create a separate script to manage the player animations. So let's right-click, create a new C# script, and let's call it Player Animator. Okay, I'm going to select my player and attach the Player Animator script to it, then open it. Cool. So this is our second script here. First, we will need a reference to the animator that we've got right here. attached to the player animator game object. Here it is. So let's add a reference to it because we want to control it and change the animation to the run animation. So again, I'm going to create a header. Let's call it elements or components. Serialize field animator, animator. Okay, here we go. Now if we go back to Unity, we will spot a field inside of the inspector. Here we go. So now we can attach our animator and control it. So basically, whenever we start running, we will need to call the animator and tell it to switch the current animation to the running animation. And by the way, I want to rename it run. Yeah, I think it's better in my opinion. I think it's better. Okay, so let's go back to Unity and create a new method. So let's make it public because we want to call it from the player movement script. Public void play run animation. Like so. Okay, here we go. In here, we are simply going to call the animator and tell it to play the run animation. So this is the syntax you want to use if you want to play a certain animation. Cool. So now inside of the player movement script, what you can do is inside of the start method, call the player animator and tell it to run, or you can create a separate method for that. So instead of calling the move animation from here, what I'm going to do is set up a new method. So private void start running. Okay. So inside of here, I'm going to call the player animator and tell it to play the run animation. But I don't have any reference to the player animator yet. So let's add it. So again, header, elements or components as you wish. Private player animator. Perfect. Now Unity knows what the player animator is. So I'm simply going to call the play run animation. Okay, cool. So let's first test that. I'm going to call the start running animation from the start method. Okay, so that the player starts running at start. And just after that, I'm going to show you a better way of managing that. So now let's go back to Unity, select our player. We need to reference our player animator. Perfect. Let's open the scene and hit play. Here we go. Now our player is running. Okay, he's running too slow, but he's running. Let's try 5. Yeah, better. 10 maybe. Okay, this is way better. It does match his footsteps. Cool. So it means that we are going to use 10 for our move speed. Perfect. For now. Just for now. I think we are going to change it later on, but yeah. Just step by step. Okay. Anyway. All right. So now let's go back to our script and manage our running a bit better because right now he's running from the start and playing the move animation and so on. That's not what we want. We are going to add multiple states to our player. Okay, so for that, I'm going to use an enum. So let's write enum. Let's call it state. We will have an idle state, a run state, and for now, that's okay. But later on, we will have 2 more states, okay? So this is a custom type. So now let's create a variable of that type. So private state, let's call it state. Cool. So at first, we will initialize our player state. So state equals state.idle, because at first, he should not be moving until we press the play button. So let's remove the start running call from here. Then what I like to do is create a custom method again to manage our states. So manage, let's say states, or manage state. Yeah, that's better. Now I can remove the move method from here and call the manage state method. Perfect. So in here, we are going to use a switch statement. So switch state. So it will apply different logics depending on the value of state. So in case our state is the idle state, we are going to apply some logic and then break. Okay. But in case our state is the run state, we are going to apply some different logic and break. Okay, cool. So what do we want to do if we are currently in the idle state? Well, Nothing. Simply nothing. Okay? But if we are in the run state, we want to move. Okay? So we want to call the move method to be able to move our player to the right. Perfect. So now whenever we call our start running method, we want to change the state to the run state. That way, it will switch here to this logic and call the move method. So now we just need to call the start running method to be able to start moving. So let's go back to Unity and give a shot. Let's just hit play, and the player should not move. Okay, cool, he's not moving, he's just playing the idle animation. So now let's add a way to switch to the start running animation. What I'm gonna do is add a condition inside of the update method. So if we press, let's say, so input.getKeyDown, keycode.space. So if we press the space key, okay, we should start running. And this is just for testing purposes. Keep that in mind, because on your phone, you don't have a space key like when you're playing a game. You could change the logic to check if the player has pressed the screen, but yeah, we are not going to use that now. So let's go back to Unity, hit play. Let's press the space key, and the player has started running. Awesome. So now this is working really well. And this is called a state machine because you'll apply different logics depending on the state of an object. You can use this logic for your enemies, for anything you want in your game. Okay, cool. So now that our player is running and that we know how to manage the player states, in the next one, we are going to improve the graphics a bit more. And yeah, this should be good because I don't like you looking at the Unity default skybox for too long. Yeah, it can cause some trauma. Anyway, so yeah, see you in the next one. All right, welcome back, guys. In this lesson, we are going to make our scene a bit more pretty because, yeah, make sure to do that as you go because it's going to make your project way more easy to work on. Okay, so let's first add a ground. So let's right-click, select 3D object, cube. Let's reset its transform by right-clicking, reset. Perfect, here we go. So now we can notice that our player is really big. And that's not what we want. So we want to make it a bit smaller because it's going to be easier to deal with. Or you can make your cube and all of your world elements much bigger. So as you wish, actually. Make sure to use the logic that you want. So I like to make my characters a bit smaller. So let's select our player, animator character right here. Let's select it. You can either play with the scale. Let's first enable the constraint proportions and set 0.5. Yep, seems decent. 0.3. Okay, cool. Yeah, you could do something like that. And let's actually use that logic. Okay, so let's say that we want to use a 0.3 scale for our character. It fits inside of this pool. Okay, now I'm going to grab our cube, drop it down so that the feet of the player are on the ground. Cool. Let's now increase this. So I'm going to press T inside of the scene view. Let's go back to our view right here along the Z-axis. And let's scale this down. Perfect. I'm also going to scale it horizontally by holding Control and Alt. Perfect. Something like that should be good. Nice. I think you should also scale it across along the Z-axis. Okay, here we go. Maybe 5 for the scale. Perfect. Okay, so now we have our first platform. Let's call it ground. I'm going to keep the the box collider, even though we don't need it right now. But what I want to do is change the material of this ground because I don't like its color. So I'm going to create a new folder inside of the Frankie Trigger folder. Let's call it materials. Let's now right-click, create a new material. Perfect. Let's call it ground. Grab it and attach it to our ground. I'm going to reduce the smoothness because it should not be smooth. And change the color to something a bit darker. Let's say, I don't know, something like that. Yep, that's better. But now our character doesn't pop out. So we will definitely need to change our character materials or colors. So let's make the ground like so. Perfect. I like it. Now let's change the colors of our player. So when we select our player right here, so the character game object, the one that has the skinned mesh renderer, you can notice that it has 4 materials right here. So let's create a new folder inside of the materials folder, call it player, and let's create these materials one by one. So let's create a new material. Let's call it skin, let's say. It should not be smooth. Okay, so the skin color is the material 001. So let's replace it. Perfect. I'm going to make it orange. Like it should be bright. Okay, here we go. Nice. I think I'm also going to change the colors of his shirt and so on. Because, yeah, I don't like the colors. But yeah, feel free to change whatever you want and keep whatever you want. Here we go. That's better. But one thing that I notice is that there are too much shadows right here. So what you can do is select the lighting tab. And if you can't spot the lighting tab, select window, rendering, lighting. Here we go. Then you want to select the environment tab right here and change the environment lighting source to gradient instead of skybox. So now I'm going to change the colors to some bright colors. So white for this one, a bit more white for this one too. And let's keep this one. Let's add a bit of shadows to the ground color. Perfect. So if you ask yourself, what does that do? The ground color changes the color of the vertices or the faces that have their normals facing down, let's say. So if you change it, you now notice what parts of the character it does affect. The equator color changes all of the faces that have their normals facing like horizontally, if you know what I mean. Got it? Better. Got it? Better. Okay. And yeah, the sky color is the opposite. Their normals facing up. Okay, cool. So now that we have a shiny character, let's change our skybox because yeah, this is a bad one. Okay. Let's open the asset store. I'm going to look for a skybox. And I want a free skybox because I don't want you guys to pay, but if you want to pay for a skybox, feel free to do so. Cool. Which one should we use? Maybe page 2, we can find something great that fits our hyper casual style. Page 3. Okay, here we go. Let's use the Farland Skies Simple Cumulus. I like this one, the blue one right here. So let's add it to your assets and open it in Unity. Perfect, here it is. I have already downloaded it, so I'm just gonna import it. Okay, so in my case, I like the blue one. So what I'm gonna do is disable or select none to import anything, to import nothing. And I'm manually going to select the simple cumulus gradient, so this one, along with its textures. Perfect. What else do we need? Nothing, because these are some other skyboxes. And yep, they won't fit our style. Maybe the red one, but the character is already orange, so we won't have much contrast. Okay, anyway, so let's import the one we've selected. Import it. Perfect. Let's close the package manager window. Select lighting, environment, and change the skybox material to the simple cumulus one we've just downloaded. Here we go. Now we have a nice hyper casual feel or some nice graphics. Okay, so what you can do is also change the color of the gradient right here. So you can change the exposure as you wish. I'm going to keep it to 1. You can change the rotation. And you can also change the tint color. So let's use, I don't know, let's use a bluish color. Something like that should be good. Yeah, that's better. That's cool. And feel free to play with these colors and make it fit your style. Okay, so now that we have some nice graphics and better visuals to deal with, in the next lesson, we are going to see how we can animate our characters one step further. So see you in the next one. Welcome back, guys. In the previous lesson, we've learned how to improve our game graphics, and it's now so much easier on the eye. In this one, we are going to analyze a bit more Johnny Trigger, so how they do stuff, and try and apply the same logic. So let's open our web browser and watch a bit of Johnny Trigger's gameplay. So right now, the player is always running. Then, whenever he enters a certain area, he starts playing an animation. So he's running, and now he's playing an animation. So this is what we are going to do. Basically, we are going to add an invisible object, and whenever the player enters or hits that invisible object, we are going to follow a certain path and play a certain animation. Got it? I hope this is clear. If not, let's jump right into it. Okay, I'm going to remove this, open Unity again, and start working. Okay, so let's first add our invisible object. So let's say we want to add it. Let's first imagine our scene a bit more. Okay, so the player is running at first. We are going to duplicate our ground by hitting Control D. Let's move it somewhere around here, let's say. Okay, so I want the player to do a backflip, a front flip, sorry. Let's duplicate this again and place it somewhere around here. Okay. So these are overlapping. Now they are not. Cool. So if I hit play, now the player is gonna be running. Oh no, he's not. I need to press space. He's running now. Whoa, 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 whoa. That's too fast, bro. Come on. Calm down. So I need to reduce the move speed. Let's say 1. Press space. Okay, that's too slow. Maybe 3. Here we go. 3 is better. Okay, so I'm going to quit the play mode, set this to 3. And one thing that I notice here is that we don't have a camera following the player. So you know what? Instead of adding our logic for playing the animation and so on, we are going to manage the camera now. So Unity has a cool package to manage cameras, and we are going to use it. So let's select Window, Package Manager, select the Unity registry, and search for Cinemachine. Now we are going to install it. Perfect. When it's done, we can close the Package Manager window. We can now right-click, select Cinemachine, and add a virtual camera. Cool. So let's call it Player Camera. We can reset its transform. Cool. And one thing you notice is that the camera or our view has changed. Why? This is because our player camera right here is now controlling our main camera. Now you can't move your camera anymore unless you disable the Cinemachine brain. Now you can move it again. Okay? So let's enable our Cinemachine brain. Perfect. And let's configure our player camera. I'm just going to drop it after the main camera. That's better. So the first thing we are going to do is add a follow transform to specify the camera what we need to follow. So we need to follow the player. Perfect. So it has centered on the player now. And we also want to look at the player. So let's set it as the look at transform. Perfect. So now let's configure our body here. So the body is the configuration for the follow transform. So we don't want any damping. We want the camera to have the same X position as the player. Okay, it's going to be smoother. But we want to add a bit of offset to the right. Okay, so now it's a bit weird because it's positioned at the same point it's trying to look. Oh, by the way, I specified the player camera. Come on. I need to specify the player right here for the look at transform. So let's add a bit of offset, okay, to the right. Let's say 2. And maybe a bit more up. Okay, let's say 2, 2. 2, 2, 2, 2, 2, 2, 2, 2. Anyway, okay, cool. I think that's a bit too low. So let's say 4. And now the camera angle is weird. Why? Because it's trying to look at the player. So what you can do is either remove the look at transform and set the rotation manually, like so. Okay, so let's set it to 0. And now we notice that it's a bit too high. So 1.5, let's say, something like that. Okay, you can also play with the lens field of view. Okay, let's say 70 for this one. Perfect. And let's say you want to use the look at transform right here. So if you want to do so, you need to set up your tracked object offset and so on. So let's say we don't want any damping. We are going to add 1.5 for the tracked object offset X position, like we've done for the follow, and 2.8 for the Y axis, like we've done right here again. So what's cool about the look at capability or functionality is that you can look forward or ahead of time. So the camera is always going to track the movement of the player and look ahead of it. So that can be nice for some platformers and so on. But in our case, it's not really useful. And I can do a whole course on Cinemachine. So let's first use what we need. Okay? So what I'm going to do is maybe bring it down. Yeah, 1.3 or 1.5 should be enough actually. What about this? No, let's say 3. Yeah, here we go. That's better. I like it. So let's hit play and see how it behaves. Okay, let's press space. Here we go. Now our character is moving and the camera is following. Awesome. Cool. So that's working really well. That's one thing. So I guess we are done with the camera. If you want to play with these settings a bit more, feel free to do so because there is a bunch of them. And you can achieve so much with these. Okay, cool. And in the next one, let's learn how we can actually jump above this hold and play a nice flip animation. See you in the next one. All right, welcome back, guys. In this lesson, we are finally going to play our flip animation. Finally. Okay, come on. Let's do that. Okay, but first, what I like to do is organize my scene elements a bit more because we are starting to have multiple elements right here. So I'm going to right click, create a new game object, and call it environment. Like so. Perfect. I'm going to reset its transform and select the main camera, player camera, directional light, and global volume. Drop them onto this new game object. Perfect. Let's now create another one for the gameplay elements. So gameplay, like so. Let's reset the transform, select the player and the grounds, and drop them inside of it. And now it's well organized. I'm going to add a separator somewhere around here. Okay. And here we go. Now our scene elements are well set up and organized, of course. Okay. So to move the player or to play a cool front flip animation to jump this hole, okay, we are going to use Unity's Splines, and it's a package they just made or just released, so that's really cool. So let's import Unity Splines. So I'm going to select Window, Package Manager, Unity Registry, and write Spl. Spl for splines. If you want to write splines, you can write splines, but you can only write like the first letters. I'm going to install the package. Okay, perfect. And when it's done, we can close the package manager window. Awesome. So if you remember well, when analyzing Johnny Trigger, we've noticed that when entering a certain point, a certain trigger, the player was following a certain path. So we are going to apply the same logic for our game. So right here, what I'm going to do is create a spline. So let's right click, spline, and select the draw spline tool. Perfect. So now it has created a spline for us. Let's call it player spline. Perfect. So we already have a spline. So let's add a point by hitting the plus button right here. Cool. So it has added our first spline node or position. And here it is right here. You can see it move in the scene view. Got it? So to be able to edit the spline inside of the scene view, I'm going to select this tool right here to be able to add some points. And the issue right here is that you need to add points to a surface. So what I'm going to do is orient my camera a bit to a top view and click right here. Oh, come on, not 2 points. Okay, so it has created another spline for us. So what we are going to do instead is remove this spline and create a new one. So I want the first point to be somewhere around here and the second point to be somewhere around here, let's say. Got it? Perfect. So now let's press escape. And we now have 2 points. Cool. 2 points won't be enough. We will need 3 points to have a nice rounded curve. So I'm going to switch to the view we had, okay, and add a third point right here. So let's hit plus, and we now have 3 points. Here is our third point. Perfect. So that's actually the second one now, but that's the third point we've added. Okay, cool. So now we are going to change these tangents right here. So let's select this point and switch it to Bezier curve. Okay, so that we can manipulate the tangent a bit more. Same thing for this one. Where is its tangent? Okay, so in should be somewhere around here. Okay, here we go. Nice. So now we can play with these handles and adapt the curve or the spline to your liking. Okay? And just make sure that it is centered along the z-axis. It should be 0 along the z-axis right here. So 0 for this position 2 and for this one. Perfect. So now how can we get the player to follow that spline? Because now if we hit play, he's definitely not going to follow it. Let's press space. Nothing. He does pass through it and doesn't care. So what we are first going to do is add a trigger right here at the start of the spline. And whenever the player hits that trigger, he's going to follow that spline. Got it? So let's create a new game object. Let's make it a 3D game object. It can be a cube or any 3D model that you want. Cool. So we are going to place it maybe somewhere around here. Okay, let's try and drop it at the same position. Somewhere around here. That's cool. Yep, that's okay. We can reduce its size. Something like that. Good. And let's now just keep it visible. You can actually hide it by disabling the mesh renderer, but let's keep it visible for testing purposes. So let's now call it, let's say, Warzone trigger. I like to call it Warzone because for me, this is a war zone, that like a zone where you will shoot enemies. Now, what's left to do is add some kind of detection so that whenever we detect this trigger right here, we can tell the player to follow the spline. So let's learn how we can do that in the next lesson. See you there! Alright, welcome back guys. In this lesson, we are finally going to try and detect this small trigger right here that will enable us to follow the spline and play a cool animation. Okay, so remember I told you this was a war zone. So we are gonna make a Warzone script later on. Don't worry about that. Okay, so the first thing I want to do here is create a new script. So I'm going to open the folder where I have my scripts and create a new C# script that I'm going to call player detection. So this script will enable us or help us detect any object we want to detect. So in that case, we are going to start with the Warzone trigger. So let's grab this script and attach it to our player. Perfect. Now we can open it. Cool. Okay, so first off, we are going to create a new method that we are going to call detect stuff. Okay, like so. So in this one, we are going to detect stuff. That's pretty straightforward. So we want to call this method, let's say, on each frame. So inside of the update method, so detect stuff. Perfect. So this method will now be called. And what do we want to do in this one? So we are going to use the physics class and especially the overlap sphere method. Okay, so the overlap sphere method does return an array of colliders that you can see right here. So we need to specify a position and a radius. So let me first use it and then explain how it's going to work. So for the position, I'm going to use transform.position. So that's the position of our player. And for the radius, I'm going to specify a detection radius. Okay, so now there is an error because I need to specify the detection radius. So let's add a header for the settings, serialized field, private float, detection radius. Like so. Cool. So now I can store the colliders array returned by this method inside of a colliders array. So collider array, let's say detected objects equals this. Cool. So now if I go back to Unity, I can specify the detection radius. So let's say I'm going to use 1. But I have no way of checking how far I'm going to be able to detect, okay? So for that, I'm going to use a built-in method, which is the onDrawGizmos method. It will enable us to spot our detection radius or visualize it inside of our scene. So let's use it right away. So you can write onDrawGizmos. We are first going to set up the color. So gizmos.color equals, let's say, color.red. Yeah, should be cool. Then we can draw the detection radius. And for that, we are going to use a sphere. So gizmos.drawWireSphere. We need to specify the center of the sphere. It's going to be our transform.position. And for the radius, we are going to use the detection radius. Awesome. Let's now go back to Unity. And now we are able to spot the detection radius. So now Unity will return an array of colliders detected inside of this sphere. So right now it's a bit too large. So I'm going to diminish its size, let's say 0.25, something like that. So whenever the trigger enters this sphere, it's going to be detected. Okay? So what we can do right now is simply go back to our method right here and debug any object that we detect. So for each collider inside of, let's call it collider inside of the detected objects array, we are simply going to debug.log, so print in the console, collider.name. Okay, cool. Just to check which colliders we detect in Unity. So now I'm going to open the console. Again, if you can't spot the console, it's in Window, General, Console. So let's now hit play, and we can already notice that we are detecting the ground. Perfect. So if I hit space, boom, it did detect the Warzone trigger. Now it's detecting the second ground. Cool. So we now have a way of detecting objects in Unity. That's awesome. There are multiple ways of doing that, but this one is useful. There is another one using rigid bodies, but for now, our player doesn't have any rigid body, and we don't need it because we are controlling our movement like with splines and so on. Perfect. So now that we are detecting objects, we need to check if we did detect a Warzone trigger or not. So for that, we are going to select our Warzone trigger and add a tag to it. So let's add a new tag. Let's call it Warzone enter. Okay, perfect. Now we need to select our object again and change its tag to the Warzone enter tag. Now what's cool about this method is that we can check if the object we've collided with or detected has that specific tag. So if collider.compare tag Warzone enter, then we can call a specific method. Let's call it entered Warzone fallback. We can also pass in the collider because we might use it. Okay, so private void entered Warzone fallback collider, or let's say Warzone trigger collider. Okay, perfect, cool. So now we know that we've collided with a Warzone enter. That's already a nice step towards our goal. Cool. So now we need to follow this spline whenever we trigger the collider. How can we do that? Well, we can simply look for any spline inside of our game, but it's not a clean solution because we might have multiple splines. So in the next lesson, let's actually implement our Warzone just to make things a bit cleaner. See you in the next one. All right, welcome back, guys. In this lesson, we are finally going to implement our first Warzone. Should be pretty interesting, huh? All right, so let's right-click inside of our gameplay game object, create a new game object, and let's call it Warzone, let's say 00, okay? This is going to be the first one. So the Warzone will contain the player spline and the Warzone trigger. Cool. So now let's create a new script for this Warzone. So let's open the scripts folder, right-click, create a new C# script, and let's call it Warzone. Okay, cool. Let's now attach this script to our Warzone game object and open it. Perfect. Now that's interesting. Why? Because whenever we detect the Warzone trigger collider, what we can do is look for a Warzone script inside of the parents of the Warzone. So we've triggered this one. We are going to check if its parent has a Warzone component attached to it. And if that's the case, we can tell the player to follow that spline. So the Warzone will have a reference to this spline and we'll be able to provide it to the player for it to follow it. Got it? Cool. So let's jump back to our script and grab the Warzone component that is attached to the parent of the trigger. So Warzone equals Warzone trigger collider dot get component in parent. So get component in parent of type Warzone. Perfect. So now we have a reference to this to our Warzone. So what we can do it is pass it to the player movement script. This way we will be able to follow this spline. Got it? So we need to add another state in here. We need to add the Warzone state. Perfect. We will also add a new case. So case state.warzone. We will apply some logic later on right here. Perfect. Let's now go back to our player detection script. Add a reference to our player movement. So let's say elements, serialize field, private player movement. This is one way of doing things, but if you are sure that your player detection script has a player movement script attached to it, and you don't want to clutter your inspector right here, what you can do is add an attribute at the top of the class. So let's say require component type of player movement. So that way it will make sure that anytime you add the player detection script to a game object, it will also add a player movement script. So now I can keep this private, like so that I don't see it in the inspector, and reference it right here in the start method. Player movement equals get component of type player movement. Perfect. So it does help declutter the inspector a bit more. And it's another way of doing things that I wanted to show you. I hope this is useful. Okay, anyway. So right here, now that we have the Warzone, we can call the player movement script and tell it that we have entered a Warzone. So entered Warzone, let's say callback, something like that. Yep, same name. Let's pass in the Warzone. And now we can create that script inside of the player movement script. So let's open it. Let's create a public method, void entered Warzone callback. It should take a Warzone as an argument. And we should be good. Nice. So now let's test that. I'm simply going to debug.log entered Warzone. Perfect. Let's now go back to Unity and check if we call this method. So let's hit play. Okay, I'm going to hit space. Boom. Entered Warzone. Perfect. So now the player movement knows that he has entered a Warzone. One thing that bothers me is that we enter the Warzone 17 times. So we should only enter it once. So there are multiple ways of preventing that. One way of doing things is that you can store a reference to the current Warzone in the player movement. And if the player movement is already in a Warzone, you can just not debug or not apply the logic anymore. So let me show you how you can do that. So here we can create a private reference to the current Warzone. So let's say current Warzone, okay. Inside of the entered Warzone callback, we can check if the current Warzone is different than null, we can simply return. That way we are not going to debug or apply the logic multiple times. If that's not the case, we can set our current Warzone to the Warzone that we've detected. Cool. So now let's give it a shot, and hopefully we should debug this line only once. Okay, let's now hit space. Awesome, only once. So that's pretty cool. Okay, awesome. In the next one, now that we have a reference to our Warzone, we are going to try and follow this nice spline. See you in the next one. All right, guys, welcome back. In this lesson, we are finally going to get the player to follow the spline. It's gonna be quite interesting, so yeah, just stay focused. All right. So now the player knows that he has triggered a war zone. We also have a reference to that war zone. That's cool. So now we are going to add a reference to the spline inside of the Warzone script. So let's first do that. So elements, serialize field, private spline. Oh, this is not working. Why? Because we need to add the spline library. You need to write using Unity engine.splines, and now Unity knows which spline class you want to use. Awesome. So private spline, let's call it player spline. Okay, perfect. So now the Warzone has a reference to the player spline. What you can do now is either create a public method that will return a spline, let's call it get player spline, and it will simply return the player spline. Perfect. That way we can use that in the player movement script. So as we know that we need to grab the spline from the player movement script, we are going to create a method for that. So public spline get player spline. Perfect. And this will simply return the player spline. Cool. So now in the player movement script, we can use that spline to tell the player to follow it. Okay, got it? Perfect. So let's try and follow that spline. To achieve that, we are going to call a method from the Warzone state right here inside of the manage state method. But right now, we are still not in Warzone state, right? So what we can do is set state equals state.warzone. Perfect. So now we are not going to call the move method anymore. What we want to do is call another method, and let's call it manage Warzone state. Like so. Perfect. Let's drop it, let's say, after the entered Warzone callback. So private void manage Warzone state. Cool. So inside of this manage Warzone state, what do we want to do? First, let's check if the player does stop or not. So we are going to select our Warzone, and we need to add a reference to the spline, but this is not the spline that we want here. It has added a spline. We need to add a spline container. So let's rename it spline container. Perfect. And this should return the player spline.spline. Awesome. Now, if we go back to Unity, we should now be able to specify the spline container. Got it? Cool. So let's now hit play. Let's press space, and the player did stop indeed. Awesome. This is working really well. So he's still running, playing the run animation, but he did stop, which is cool because now we can tell it or tell him to follow this spline. How can we do that? Let's go back to our player movement script and start coding this. So the spline class comes with a useful way to get the position at a certain point on the spline. To be able to check that method, I'm going to hold Control and press the spline container class right here. And right now, you can notice that we have a evaluate position on a certain spline at a certain point in time. So the parameter t right here should be between 0 and 1. This is just a % on the spline, okay? We can use this method inside of the player movement class. So what we can do is write current Warzone dot get player spline dot evaluate position, but we can't use that method because we need to add a reference to the splines class again. So using Unity engine.splines, perfect. And now we should be able to call the evaluate position. Okay, so we are going to evaluate the position of that spline at a certain %. So let's call it spline % for now. Okay, so we can make that a parameter. Let's drop it somewhere around here, maybe. Let's make a new header, spline settings. Okay, so serialize field, private float, spline %. Cool. So this does return a vector 3 or a float 3. And what we can do is set the position of the player to that position. So transform that position equals this. So now we can give it a shot. And what's cool about that is that we can now control at which percent the player should be. So let's select the player, hit play. Okay, let's press space. So now it is 0. So if we increase it, we can notice that it does follow the position of the spline a bit weirdly, but it does indeed. Why is the player not following the spline correctly here? This is because our player spline is offset. If you right-click on the transform component and reset it, you now notice that the player is actually following the spline correctly. It's just that our spline wasn't correctly set up. So what we are going to do is exit the play mode, select the spline, reset it, and move all of the points to the right. So to do so, you can select the spline tool, select all of the points, and move them to the right. Somewhere around here should be good. Okay, let's now hit play, and hopefully this should work really well. So I'm going to select the player again. By the way, I should hit play first. Cool. And increase the percent. Awesome. Now it's working really well. Okay, so now it's kind of manual, so it's a bit archaic. So what we are going to do is automate this. Let's now go back to Unity. And instead of moving this spline percent manually, I'm going to remove it from here, let's say. Okay, so it should be private. And I'm not going to call it spline percent, but I'm going to call it Warzone timer, let's say. And initially, our Warzone timer is equals to 0. And whenever I enter a Warzone, what I'm going to do is reset it again, set it to 0. After that, inside of the manage Warzone state, I'm going to increase this timer. So I'm going to add time.delta time, so the interval between 2 frames, on each frame. To get the spline percent, so float spline percent, is going to be equals to the Warzone timer divided by the duration you want for the Warzone. So let's say I want the player to cross the Warzone in, let's say, I don't know, 2 seconds. It should be Warzone timer divided by 2. And this does give us a percent. So let's try that. And then we can specify this duration inside of the Warzone script. Okay? It will be more reusable because some Warzones will last 1 second. Some other Warzones may last 3 seconds, 4, 5. Anyway, you will be free to change that as you wish. So let's first hit play. Okay. And let's count together. So after entering the Warzone, the crossing should take 2 seconds. 1, 2, here. Nice. It did take 2 seconds. Indeed. Cool. We can now control the duration of our movement right here. So let's say you want it to last 3 seconds or 5 seconds. Yeah, let's say 5 seconds. Let's go back to Unity. Let's hit play. I'm going to press space. 1, 2, 3, 4, 5. Boom. Nice. 5 seconds, indeed. Cool. So now the player is finally following that spline. Awesome. Now what we are going to do in the next one is, as I've told you, add a parameter here or an argument to be able to change the duration of the Warzone as we wish. And we are also going to specify an animation that we want to play while following the spline. It's going to be really interesting again. The whole course is interesting actually. So yeah, stay tuned. See you in the next one.